In this video, we will solve an interesting problem from the Math Overflow forum. Before we start, subscribe so that you don't miss new videos. To begin with, let's remember that the rook moves horizontally and vertically, while no more than n unbreakable rooks can be placed on a square board with side n. Let's try to understand how many ways you can arrange unbreakable rooks in a 4x4 square. 0 rooks can be placed in one way. 1 rook can be placed in 16 ways, while 9 cells remain for the second rook, and each method is counted 2 times. There are 4 cells left to place the third rook, and each arrangement will be repeated 6 times. Similarly, we count the arrangements for 4 rooks. The resulting number did not accidentally turn out to be the denominator of the 5th number of the sequence. Let's introduce a new notation to help us solve the problem and try to express the number of ways to place unbreakable rooks on the board n by n. Indeed, if there is a rook in the first row, then the rest of the board looks like a square n-1 by n-1. This can be done in n ways. Otherwise, this is the number of ways to place rooks in a rectangle n-1 by n. In the same way, let's express the number of ways to place rooks on the board, n by n plus 1, and write it down as a sequence of 2 variables. Let's now return to our problem, and note that the sequences pn, qn, and yn minus 1, xn minus 1 coincide, which is easy to show by induction, by checking the base and proving the induction step. Thus, Qn is the number of ways to place unbreakable rooks on the board by n-1, which was required. The problem is solved. A couple of days ago, I made another video about the Olympiad problem. You can watch it until the video is over.